Pandas significantly changed display options in version 0.25, so that's not a version 1.0 change, but it's a so significant change in basic Pandas behaviors that it still causes a lot of confusion, and that's why I'm going to highlight that change again here. And I import Pandas, and I've actually downgraded my Pandas installation to version 0.24. And now I'm going to import the Titanic file from the CSV file Titanic, and I save the data frame in the variable Titanic. And now let's inspect Titanic by just printing it. And let's have a look at the default behavior we have been used to for months or even years. So by default, the Pandas shows us 60 rows. So the first 30 rows and the last 30 rows. And that was actually the standard behavior if we have a data frame with more than 60 rows. And if our data frame has less than 60 rows, then Pandas displays all rows. And the reason for this is that there is a display option called Pandas options display max rows. And the default setting is 60. And typically when we want to inspect a dataset or a data frame, it's sufficient to have a look at the first, say, 5 rows and the last 5 rows. And therefore, typically we have used the head method and the tail method. So by default, the head method shows the first 5 rows and the tail method the last 5 rows. But we can also mirror this behavior by setting max rows, for instance, to 10. And now if we reprint our data frame here, then we get the first 5 rows and the last 5 rows, because we have set the max rows to 10. Now, in case you want to display all rows, we have to set max rows, for instance, in our example, to at least 891 or 92. So let's set the max rows here to 900. And if we print Titanic again, then we should see all rows, so all 891 rows. And that's true here. So to sum up, in Pandas version 0.24 or earlier, the default behavior was that we see the first 30 rows and the last 30 rows, because the default setting for max rows is 60, and this significantly changed in version 0.25. Alright, I've updated Pandas to version 1.0, and let's understand the new behavior. So when printing a data frame with more than 60 rows, then you will see by default the first 5 rows and the last 5 rows. And let me explain the reason for this. So we still have the display option max rows with the default setting 60. And then actually Pandas added the new display option min rows with a default setting of 10. Now, whenever the number of rows in a data frame is higher than the max row setting, in the default setting it's 60. So whenever we have more than 60 rows, then the min rows option prevails. And that's the reason why we see 10 rows here. Now, what if we want to see the first 30 rows and the last 30 rows of a data frame? Then in this case, we could either set min rows to 60, or the better option would be to set min rows to none. So let's do this here. And by doing so, we have actually restored the behavior from previous versions. And we see the first 30 rows and the last 30 rows. And that's exactly the case here. And finally, what if you want to see all rows? So in this case, we have to increase the max rows to at least 891. So here we have 891 rows. And then we can print the full data frame. So what's the benefit of the new setting? And actually, typically when you want to inspect your data frame, So you require typically maybe 5 rows or 10 rows. So the first 5 rows or the last 5 rows. And by simply printing the data frame, you get by default the first 5 and the last 5 rows. So to say, you can replace the head method and the tail method. However, in case you want to display more than 10 rows, then you have to set the display options here manually. So there are pros and cons, but as a summary, I would say that it's positive, as we can save some time by replacing the head and the tail method. Alright, thanks for watching, and see you in the next lecture. Bye. Pandas version 1.0 improves and extends the output of the info method, and the output is clearer now, in particular to everybody who is completely new to Pandas. And first of all, let's import Pandas, and let's import the players data set with in total 5 football players. And actually the info method is a pretty useful method to get some important meta information on data frames. For instance, the index, the columns, the number of missing values in columns, and also the data type in columns, and finally also the memory usage. And let's have a look on the output of the info method in previous versions. So I added this here as a picture. So you should already know this here. And now let's have a look at the info method in Pandas version 1.0. And actually, again, we are starting with some information on the index. So we have 5 entries from Lionel Messi to Manuel Neuer. And in total, we have 7 columns. And then we get some information on the columns. And here we have now, in addition, some headers. So the columns are actually consecutively numbered. And so these are the column labels. Then here we have the number or the count of non-null values in these columns. And finally also the data types of the columns. So this is not a game changer, but it's nice to have, as it's definitely clearer. Thanks for watching, and see you also in the next video. Bye. We are coming now to the most important new feature in Pandas 1.0. So version 1.0 introduces new data types, so-called nullable data types. And this is still experimental, and more features and improvements will follow in the next updates. So this is just the start of a long-term evolution. And before I will show you the new data types, I want to highlight some pitfalls of the current data type system in Pandas, and to give you an idea why there's a need for improvement and more distinct data types. So we import Pandas and NumPy also, and then we import the players data set. And let's also call the info method. So in total we have here 6 columns, and actually we have strings in the first 2 columns, nationality and club. And so far the data type of a string column is actually object. And so far there's no distinct data type like string. Then next we have the world champion column, and here we have the boolean values true and false, and the data type is here bool. Next, we have the height of the players with 2 decimals. So this is a float data type. And then we have 2 columns, goals 218 and goals 219, with the number of goals for that particular player. And these are actually integers, so without any decimals. And here we can see the data type integer. And finally, we have the pretty unclean column VC, which also stands for world champion. And here we have mixed data types. So for Lionel Messi, we have false. Then for Ronaldo, we have no. Then we have a missing value for Neymar and a true for Kylian Mbappé. And for Manuel Neuer, we know that he won the World Championship with the German team in 2014. So here we have mixed data types. And actually, mixed data types are typically indicated by object. So we have string columns and also mixed data type columns, and both are actually labeled with the data type object. Next, let's import a second version of our players data frame, players2, with some more missing values. So for instance, here we have in each and every column at least one missing value. For instance, here, here and also here and here. And let's have a look also again at the data types. And actually we have here the Boolean column world champion. And here we introduced a missing value. And so far, if we introduce missing values in Boolean columns, this automatically converts the data type to object. So before, without any missing value, we had here bool data type. And now with one missing value or more missing values, we have here object. So let's have a closer look at the data frame, and let's have a look at goals 2019. And here we introduced one missing value for Neymar. And if we have one or more missing values in an integer column, this leads automatically to the conversion of the data type from integer to float. So now we have here float numbers or float data type, and we can also see this here. So if we introduce one missing value in an integer column, the problem is that all other integers are getting converted to float, and this is actually pretty bad. So this is the current status of Pandas version 0.x, and it would be more helpful and more Pythonic to have in string columns the data type string than in a Boolean column where we have missing values still Boolean, and in an integer column with missing values, we want to have still the data type integer. So that's the goal actually, and Pandas starts to solve this issue in version 1.0 and hopefully also the next versions. And in the next video, we will have a closer look at the new behavior. So hope to see you there. Bye. Alright, we have still imported the players2 data frame, containing some data types that are not optimal or even misleading. And now Pandas 1.0 introduces the method convert dtypes. So let's have a look inside here. And if we run the method, then Pandas tries to convert columns to the best possible data type. So let's call the convert dtypes method on the players2 data frame. And we store the new data frame in the variable players3. And that's here players3. And at a first glance, we can see that the missing values have changed from NaN to NA. And this holds true for string columns, Boolean columns, and also integer columns. So in the float column height, we still have NaN. So now let's also call the info method on our new players3 data frame, and let's inspect the data types. And here in the columns nationality and club, we have the new and distinct string data type, which is an extension data type dedicated to string data. So again, previously strings were typically labeled as object dtype. And let's have a look here at the world champion. So here we have the new and distinct Boolean dtype, which is also an extension dtype dedicated to Boolean data that can hold missing values. And we shouldn't mix this data type, this new data type Boolean up with the old one. So let's have a look at our players data frame. And here we had the old bool data type, so we shouldn't mix the Boolean and bool up. So this is the new nullable data type Boolean. So the old and still default bool data type bool can only hold trues and false and cannot hold or handle missing values. And this problem is solved here with the new Boolean data type. And finally, we also have the new and distinct integer data type. And here we have a capital I, so this is a capital letter. And we shouldn't mix this up with the old integer data type int with a lowercase I. So this is the new nullable data type integer. So the new integer data type is dedicated to integer data and can also hold missing values. All right. And at this point, it's important to mention that these new data types are still experimental and they can change at any time. So the new data types are not the default or standard data types when working with pandas. And we have to explicitly convert the old types into the new types with, for instance, convert D types. However, Pandas recommends using the new ones, but we should still be careful. And of course, in the long run, the plan is to establish the new data types as the default or standard data types. And this could happen in one of the next updates. So it's definitely recommended getting familiar with the new data types. And actually I said that the new data types are also called nullable data types, as they can hold and handle missing values. And the designers of Pandas needed to create a complete new representation or concept for missing values. And in the next video we will have a closer look at this new feature. So hope to see you there. Bye. Alright, together with nullable Boolean and integer data types and the dedicated string type, Pandas 1.0 introduces also a new representation for missing values, pd.na, and this change is pretty obvious. So first of all, let's have a look at players 2 with the old data types. And here we have for missing value nan, and let's simply select one element here. So for instance, the nationality of Cristiano Ronaldo. And here we get nan. And actually nan is originally coming from the NumPy package. So we have np.nan or nan. And now let's have a look at our new data types in the players 3 data frame. And still we have the missing value here in the nationality of Cristiano Ronaldo. And let's select the element here. And here we get NA, and let's also check the data type of the new NA. So this is a special Pandas NA type, which was introduced in Pandas version 1.0. And we can also check this here. So we have pd.na, and this gives us here NA. And actually with pd.na we can also create more missing values. So for instance, the very first element in the first row, in the first column, Argentina, we can remove that and create a missing value with pd.na. And then we have here an additional NA value. And the goal of pd.na is to provide a missing indicator that can be used consistently across data types. Because up to now, Pandas uses several values to represent missing data. So we have np.nan, and this is used for float data, and np.nan and nan for object type data, and pd.nat, so nat stands for not a timestamp, for datetime-like data. And again, the goal of pd.na is to provide a missing indicator that can be used consistently across all data types. And actually, pd.na is currently used by the nullable integer and Boolean data types, and also the new string data type, and it's not yet used by float data types. And actually, it's not only that pd.na looks different than, for instance, np.nan, but compared to np.nan, pd.na has slightly different behaviors in some operations. And in general, missing values propagate in operations involving pd.na. And this means that when one of the operands is unknown, the outcome of the operation is also unknown. And this makes completely sense. And let's have a look here at some examples. So if we add a missing value with 1, then the result is still a missing value. So we simply do not know the result. And the same holds true also for np.nan, so there's no difference here. So in arithmetic operations, pd.na and np.nan propagate, but in contrast to that, in equality and comparison operations, pd.na also propagates, and this deviates from the behavior of np.nan, where actually comparisons with np.nan always return false. And let's have a look at some examples. So if we compare an unknown or missing value with 1, so we check whether the unknown or missing value is greater than 1. consequently we get a unknown value, so we simply do not know this. However, in contrast to that, np.none returns here a false. And let's have a look at some more examples. So if we use here an AND operator, and if we have a missing values and true, then we get here also a missing value. So the rule is that we should only get a true here if both conditions or statements are true. And as we simply do not know here the statement, therefore we also do not know here the result. So if we use an AND operator, then all conditions must be true. And it completely makes sense if we compare pd.na and false, then it's pretty clear that not all conditions are true. So we have here one false, and this gives consequently also false. And now let's come to the OR operator, and at least the one condition must be true. And if we have pd.na or true, then this gives a true, because at least one condition is true, even if we do not know pd.na, so this is a missing value. And finally, if we have pd.na or false, we get a missing value. So if the missing value is true, then we should get a true, and if it's false, we should get a false. But we simply do not know the missing value, and therefore we get na as result here. And finally, it's important to highlight that also the new missing value, pd.na, behaves very similar to np.none. So for instance, the method isNull checks for each and every element if the element is missing or not. And this works pretty much in the same way as before. So let's run the cell here with our player's 3 data frame. And we get a true where we have actually missing values. Alright, thanks for watching, and I'll see you also in the next video. Bye. In this video I will show you some more details and advantages of the new nullable integer data type. And here in the player's 3 data frame we have the new integer column goals 2019, even if it contains one or many missing values. And that's definitely an improvement. And there are actually some more ways to convert from old to new integer data type. So we already used the convert dtypes method on data frames, but we can also create a Pandas series with the new integer data type from scratch. So we can use pd.series, and we have 3 elements, 1, 2, and none, which stands for a missing value. And we simply have to pass integer 64 to the dtype parameter. And it's important to use here integer with a capital I. So let's have a look at the Pandas series S. And here we can see we have the new integer data type with the one missing value. And as another option, we can also use the S type method. And we could select the column goals 2019 from players 2, which contains the old data types. And we can convert the old integer data type to a new with S type, and again we pass integer 64 with a capital I. And also here we have now the new integer type with a missing value. And now let's come to some more advantages of the new integer data type. So having the new nullable integer data type makes the select dtypes method even more powerful. So with the select dtypes method, we can select all columns with a specific data type. And from Pandas version 1.0, we can also pass integer 64 with a capital I. And we get all columns here. So goals 2018 and goals 2019. And now let's come to the next advantage. And let's again print the players 2 with the old integer data type. And here we can see that the missing value automatically converts the whole column into a float. And again, if we have comparison operations like greater or equal to, then this makes a difference. So first of all, let's try the following with players 2. So we want to verify for each and every player whether the player scored more than 20 goals in the year 2019. And here we get a true for Messi, a true for Ronaldo, And now we have a missing value for Neymar Jr. And by default, we get here a false. And this is actually not really correct. And finally, we get a true and a false for Kylian Mbappé and Manuel Neuer. So that's the behavior with the old integer data type. And now let's have a look at the new behavior. So we use here players 3. And again, we get a true for Messi, a true for Ronaldo. But then for Neymar Jr., we get a missing value because we simply do not know the number of goals. And therefore, we cannot verify whether the missing or unknown value is greater than 20 or not. In this lecture, I will show you some more details on the new string data type and why it's beneficial to use it. So we have still here the players 3 data frame with the new data types. And we have actually 2 columns with text data. So we have nationality and club. And here at a very first glance, it's pretty clear that we have text or string data. So that's definitely an improvement. And actually, we also have a third column with string data type. It's the VC column. And here we have mixed data types. So we have booleans, a string, then a missing value, booleans, and actually a number or integer. And here with the new string data type, it's at a first glance pretty clear that all elements are actually strings. Because like in a NumPy array with mixed data types, the string data type is the least common denominator, so you can convert a number and also the booleans true and false to a string. And therefore, all elements here in the mixed column are strings. And this is pretty clear here. And as a short recap, mixed data type columns are always a problem. And I call it messy data or unclean data that needs to be cleaned anyway. And here with the new data types, it's clear that we need to clean or remove this column here. And actually before with the old data types, this wasn't clear because we had the data type object. So let's have a look at players 2 and the data types. So here we had object for a column with mixed data types. And in these cases, we had to examine some elements. So for instance, the element 2014 in more detail to make sure that we have a string here. So let's select here 2014. And also with the old data types, this was or is a string, but it's not really clear here by the data type. So before we converted those 3 columns here to string data type with the method convert dtypes, but there are also some other ways to construct a new string data type Panda series or column. And the first option to use pd.series, and we create a Panda series with 3 elements, a cat, then a missing value and dog. And now we can actually pass the string to the dtype parameter. So let's have a look here. And this is a Panda series with the new string data type. And of course, we can also use the as-type method and pass the string to the dtype parameter. So this works as well. Now let's come to some more advantages of the new string dtype. And actually, the old object dtype caused some problems in dtype specific operations like here the select dtypes method. And actually, there wasn't a clear way to select just the text columns while excluding non-text, but still object type columns. And this changed here. So now we can pass the argument string to the include parameter of the select dtypes method. And then we get all columns with text data, so nationality club, and also our mixed data type column VC with strings only. However, it's important to mention that the usual string accessor methods still work in almost the very same way. So let's focus on the club column. And here we can apply the str.upper method to actually convert all characters here to uppercase. And this still works. And actually, where appropriate, the return type of the series or columns in a data frame will also have a string data type. Next, let's check whether the club names contain FC. And of course, we can do this with str.contains. And here we get actually a Panda series with the new Boolean D type. So we have here trues and false and a missing value for Kylian Mbappé. Next, we could also count the number of A's in the club names with str.count. So here as a result, we get a Panda series with integers. And also here actually with the new integer D type. So we have 2, 0, 1 and also a missing value and 1. And finally, for instance, we can also split all club names at a white space. And here we get a Panda series with object D type. So 4 elements are a list and 1 element is the new pDNA missing value. Alright, thanks for watching and see you also in the next video. Bye. Here are some more details on the new nullable Boolean data type. And again, it's called nullable because it can hold and handle missing values. So here we have the new Boolean data type Boolean in the world champion column. And it shouldn't be mixed up with the old bool data type. And also here there are several ways to create a Panda series or a column with the new Boolean data type. So for instance, we can create a Panda series from scratch. And we have, in this example, 3 values, true, false, and a missing value. And we can pass Boolean to the deep type parameter. So this works. And also we can use the as-type method and we can pass Boolean. And also here we have the new Boolean data type with a missing value. And again, this helps us in data type specific operations like the select dtypes method. And also here we can pass Boolean to the include parameter. And here we get all columns with the new data type Boolean. In this example, it's only 1 column here. And finally, let me explain the probably most important improvement of the new Boolean data type with an example. So we've already seen that the behavior in comparison operations can differ. And here we have 5 football players, and actually all football players have one goal, winning the most 2 prestigious titles, the World Championship with the national team and the Champions League with the club. And in the World Championship column, we have actually the information whether the player already won the World Championship or not. And obviously here we have 1 missing value for Manuel Neuer. And now let's add a new list that indicates whether the player has already won the Champions League. So we create here the list CL. And obviously all players except 1 already won the Champions League. So we have a false here for Kylian Mbappé. And now let's assume that we want to find out for each and every player whether the player has won at least 1 title. So we can verify this with an OR operator. And we should get a true for all players where we have at least 1 true. And with the old data types by default, we get a false on comparison operations where we have at least 1 missing value. So first of all, let's do this with the old data types and the player's 2 data frame. So we select the values in the world champion column and we have OR the values in the Champions League list. So let's have a look here. And actually we should get a true for all players. So for instance, for Lionel Messi, we have false or true, which gives a true. Then we have for Ronaldo, false or true, which gives also a true. Then for Neymar, we have false or true, and this gives also a true. Then we have for Kylian Mbappé, we have true or false, which gives also a true. And finally, for Manuel Neuer, we have a missing value or true, and this should give a true, so at least 1 title. And we know that he won the Champions League title. But with the old data types, we get here a false by default, because we have at least 1 missing value in the operation. And obviously this result is incorrect. And exactly here we have the improvement with the new data types and the new missing value pd.na. So let's try to do the same with the players 3 data frame. And here we get the correct results, so we have a true for all players. Alright, thanks for watching, and see you also in the next video. Bye. We are coming now to a small but pretty useful enhancement, the addition of the ignore index parameter to several Pandas series and data frame methods. And this enables us to save some code. And let me show you how it works. So we import Pandas, and then we import the players data set. So in total we have here 8 columns, and on the left hand side we have a range index starting from 0. And now let's assume that we want to sort the players by the height from high to low. So we can do this with the sort values method, and we pass the column label height, and we pass false to the ascending parameter, so from high to low. So here we have sorted our players by the height from high to low. And actually we can see on the left hand side that we have the original row labels. So for instance 4 for Manuel Neuer. And we do not have any more the range index. But typically in many cases we just want to keep the range index. So starting from 0 till 4 here. And so far we had to chain the reset index method here. And then we need to pass true to the drop parameter to actually drop the former index. So let's run the cell here. And here we actually restored the range index. So this is how we did it up to now. But now there's a better solution. So let's delete the reset index method. And there's actually the new parameter ignore index. And by default it's set to false. And this means that if we sort the rows, then we actually keep the original index labels, but we can also pass true. And if we pass true, then the resulting axis will be labeled 0, 1, 2, 3, and so on. So effectively we restore our range index, and that's exactly what we are going to do now. So we pass true, and let's run the cell here. And here we can see that we have automatically reset the index, and still we have a range index. So the addition of the ignore index parameter to the sort values method definitely makes sense. In addition, the ignore index parameter was also added to the drop duplicates method. So let's have a look here, and we import the players 3 data frame. And here we have a duplicate entry, so we have 2 times Lionel Messi. And now we can drop duplicates with the drop duplicates method. And let's have a look at the result here. And here we can see that we have successfully removed the second appearance of Lionel Messi. However, we can also see that we have still the original index labels. So we have 0, 1, and then 3. And typically this is not our intention, and actually we still want to have the range index. And again, either we chain here the reset index method, or we simply use the ignore index parameter. So we set the ignore index parameter to true, and by doing so we actually reset the index and we get a brand new range index. Alright, thanks for watching, and see you also in the next video. Bye. Alright, we are coming now to a very important issue, the removal of prior version deprecations. And this is so crucial that it's highlighted right at the top of the new Pandas 1.0 website. So let's have a look here. And here we can see the clearly visible note that the Pandas 1.0 release removed a lot of functionality that was deprecated in previous releases. And it's recommended to first update to Pandas 0.25 and to ensure that your code is working without warnings before you upgrade to Pandas 1.0. And that's definitely a serious issue. However, good news for you is that in case you have closely followed my course, and in case you only use the code that I use in this course, you won't have any problems here, because I'm regularly updating my courses, and therefore I don't use deprecated stuff, and I replace code once it gets deprecated. So let's have a look here at all the deprecated methods. And you can go through the list here, so it's a quite long list. And maybe you can remember the one or the other deprecation, so some of them are deprecated for years but still used, so you shouldn't do that. And actually in the next couple of minutes I'm going to show you some examples of deprecated code that is now removed in version 1.0. So let's go to my Jupyter notebook. And actually I've downgraded my Pandas installation to 0.25 to show you how the code worked in the past. And even more important, I will show you an alternative and valid code to get actually the same output. So first of all, let's import the players data set. So again, here we have our 5 football players. And actually in the previous versions, we could perform label-based and position-based indexing in one operation with the IX operator. So that's clearly deprecated, but many people still use this. And let's have an example here. So let's assume that we want to get the row with Lionel Messi. So that's label-based indexing. And we want to get the columns at index positions 1 and 4. So that's the club and goals 218. Then we can simply code the following here. So we have IX. And here on the left-hand side, we have the label or the index label for the row. And here on the right-hand side in a list, we have the index positions of the columns. And here we get the future warning message. So we don't get that in version 1.0. So in version 1.0, it simply doesn't work. And it says here IX is deprecated. Please use log for label-based indexing or ilog for positional indexing. However, we can still combine label-based and position-based indexing in one operation. So there's just a little workaround here. And actually we can get the column labels of the columns at index position 1 and 4 by actually indexing or slicing the columns index. So we get the labels at index position 1 and 4. And the labels are club and goals 218. And then we actually perform label-based indexing, and the row label is Lionel Messi. And the column labels are club and goals 218. So that's a simple workaround here. Now let's try to perform label-based indexing with missing labels. So we try to get the rows with Lionel Messi and Donald Duck. So Donald Duck is not in our data frame. But this worked in the past, and also here we get a future warning. So passing list likes to log with any missing labels will raise a key error in the future, and we should use the reindex method as an alternative. So let's do this here. We use the reindex, and then we pass the list with our labels, Lionel Messi and Donald Duck, to the labels parameter. And here we get Lionel Messi, and also we create the row Donald Duck with missing values. However, there's one limitation or restriction. So reindex only works with a unique index. So it doesn't work in case we have duplicate entries in the index. So now let's have a final example. And before there was the method PTP. And this actually returned the range in a numerical column. So the range is actually the maximum minus the minimum value. And in this case, it's 0.23. So let's have a look here. So the tallest player is Manuel Neuer with 1.93 meters. And this is the maximum value, and the minimum value is 1.7. And therefore the range is 0.23. Now in Pandas version 1.0, the deprecated PTP method is removed. And there are actually two workarounds. So either we simply calculate the max value minus the min value. Or we can also use numpy.ptp. So let's import numpy. And let's pass the height column or Pandas series to np.ptp. And also here we get the same result, 0.23. So these were some examples of deprecated and removed stuff in Pandas version 1.0. Thanks for watching. Bye.